Okay, so in this next tutorial, I'm going to show you how to analyze and what the results of analyzing multiple LCMS uh, files look like. And so here we're back, we fired up pyMS-Vis, and now what we're going to do is load 5 data sets that are available on GitHub that were also mentioned and used in the manuscript. So here I'm going to select, for the sake of time, TSV files. These were all deconvoluted by Flash Decon, and those are all my 5 files. And these files also have corresponding feature maps, MS1FTs, so I'm going to select that as my feature map. So here, I'm just going to rename them. Call them all async. Great. And then I'm happy with that. That's all the same group. I want, if I have any feature maps that end in MS1FT in the same folder as these files, that will automatically load. There is an option for no feature map, or manual means you can select one if they don't live inside the same directory. So let's process that. Okay, and here we are again. I'm gonna again do a static analysis because I just want to see the lay of the land. My mass air tolerance is a Dalton, and I'm going to leave these off just for speed. So again, these are all H2A masses. If I were to click process file, you can see it's quite speedy. If we now want to look at the outcome, all right, let's do that. Okay, so what are we looking at? So here are all the masses again that were queried. The error bars represent how much these changed in the 5 different data sets that we used that were called async. So error bars look relatively good for LCMS data from histones that were extracted from algae on different days, different conditions, asynchronously grown. However, as I mentioned in the previous tutorial, you don't want to just stop here. Always look at your data. The tabs here show the different data sets that were analyzed. And so you can see, just kind of quickly scrolling through them, some of them have quite a bit different elution behaviors because different columns were used, different, like I said, different conditions, different instruments. But if we were to zoom in on, say, this middle third data set, again, you have this cluster of masses that correspond to H2A that I know because I've done this for decades. However, you have some other masses that met our search criteria, but and are added to the quantitation, but are not related. So these are artifactual. So you want to remove them in the next round. So what I would do is I would go back to my program here, click search parameters, go back to dynamic. And now what I would do is I would go and change the regions that I want to quantify. So if we were to go to the first file here, let's do 7,500 to 9,000. Make sure they're the same. They should be the same. Here, let's do 7,500 to 9,000. Why not? Do 7,000. These ones, the elution profiles are quite a bit different. So I want to be careful here. So here I want to go 9400 to, let's say, that. And the last one I want to do, say, 9200 to, why not? Okay, let's leave these alone. Process the file. Okay, click the buttons again. Okay, let's shrink this. Okay. All right. So now, so this is without adjusting the retention time quantitation. This is with, and so you can see minor differences. And the reason for the minor differences is, again, most of the intensities are in the major peak, even in cases where you have a really strong peak spike right over there. It's only for a couple scans. So that's why there's not a lot of difference, but this is obviously more representative of your intensities than this guy, even though the error bars are not significantly different. Okay, if you loaded an MS1FT, those files happen to also have the isotopic distribution information for different masses. The dot feature files from TopFD do not have this information. So you can go in and you can click some of these masses. It gets a little bit tricky because if there's multiple ones there, it gets confused. If you want to go and take a look at the feature maps of each of the different LCMS data that you're interested in. So, again, different columns might have different, different columns have different properties, not surprising. And here in this case, while the masses are the same that are identified, you can see that the elution profiles have changed quite a bit, depending on the chemistry of the column. Okay, let's see. If we go back to the search parameters, what else can you do? Say you didn't know exactly what masses you were looking for, but you kind of had a rough idea. So in this case, let's take basically this range. Here I put in masses that were known and quantified earlier. Here, what I'm doing is I'm putting in masses and I'm searching every 3 Daltons. So it's going to be 13,488, then 3 Daltons after that, and then 3 Daltons after that, all the way up to this mass with an error tolerance of 1. So I'm going to do, it's actually going to be 13,488 plus or minus 1, and then what is that, 13,491 plus or minus 1, etc., etc. So if I do that and I keep my retention times the same and I process the file, you can get a glimpse of how that's going to change my my information here. And because we're making it work a little bit harder because we're searching for more masses. All right, so this is the outcome of that. Okay, so just kind of comparing the two. So you can see, obviously, we're searching for more. We're finding other different things that meet our criteria. Whether or not they're real is left to you to further investigate. So this might pull out interesting things that you were missing before. However, the dynamic search by range is basically should just be used for um, looking for new masses. Go back to the raw data and make sure that they really exist. I think some of these masses, for instance, might be related to one another because the window is so small. But that option is still available, like I said, for kind of more investigative um, uh, searches where if you're afraid of missing something, it might pop up with this search. Again, this tool was developed primarily to quantify proteoforms that have been extensively characterized, so you're quite sure what the masses are, and you want to relatively quickly get at histogram profiles showing similarities or differences between different runs, uh, different masses that were already extensively characterized.